So this is my assignment for MEC8056. This is the layout of the vehicle. We have 3 sensors, 3 ultrasonic sensors, one right forward facing, one left, one right. There's a magnetometer, magnetic compass in the middle. We have a servo motor driving a drag link set in the mid position for equal movement, left and right. We have a DC motor driven through a currently ratio of 1, which is waiting to be updated with real-world mechanical gear ratios for the transmission. There are automatic LEDs, lighting system triggered and controlled by a light transistor mounted on the roof to avoid shadow issues, and the front of the vehicle has a crash bumper with 2 switch detector system. Moving on to lab view. I have a fuzzy logic controller set up, which is here, with various settings. You can see prove that it works by this. This is the circuit. So this is Tinkercad, sorry. And to prove that the code, works. So we have a motor which has been sped up. See that? And then prove the other things how the motors work. So we'll change this setting for the magnetometer, and in a moment the servo motor will move. The lights go off. On again. Okay. Note that the servo motor is driven through this Arduino, and the motor is driven through this Arduino. The demand for the motor comes from here, and the signals from the magnetometer are fed back through here. So through the I2C connection, we've got dual direction transmission. So just so now demonstrate the code. That's all the setup. That's the main loop. So first of all, it calls for the updated magnetometer, so that collects the current settings from the slave Arduino. Then we do lookabout, which is pinging each of the different each of the ultrasonic sensors. Then we make a decision about which direction we want to head, and then we update the steering. We then drive the motor speed, tell the motor speed what to do, decide what we're going to do, and then we're going to update the motor with that figure. Lastly, check the lights, and then the whole thing's wrapped up in a while crash flag loop to bug out if necessary. Each function is also wrapped up in a crash flag loop if statement. So if at the earliest possible opportunity the system will bug out. So here we have magnetometer that reads the wire, so it requests from the slave into request signal, reads the wire, imports the data, rebuilds the numerical values coming through from a double through two integers into a double, then corrects for the offset values that were applied in order to be able to help it get through the system, and ultimately outputs the result to give a heading, and this code here compensates for the fact that the potentiometer readings can result in anomalous results, because this function a tan 2f gives plus or minus pi limitations, and because of rotational settings to get the potentiometer to match potentiometer position to match 0 to not be here but to be here, we need to rotate the entire frame of reference. So that's what that does, and it allows us to compensate for minus figures, which is, yeah, essentially it goes over the limit of the scope of the system, so we deal with that. Yeah, then we constrain the readings so that this device only gets what it's given, so it can go between 0 and 180 degrees, and we've got a data in the middle at 0. So we have to make sure that the demand signal we send to it doesn't ever exceed 90 degrees plus or minus. So that's what that code's doing. So we update the steering. That's us sending the steering command to the servo. Then we have lookabout. This is where we are pinging the various ultrasonic sensors: left, front, right. Yeah, so yes, that's right. So we're pinging the front sensor more often. So the idea is we sweep from left to right, and by passing through the front ping sensor, we then pass back through the front sensor again. So we collect the front sensor more often, but obviously we don't do anything with it in the meantime for now. But the idea is that you need to know what's in front of you more often than you need to know what's to each side of you. So there's, yeah, not fully implemented yet as a concept, but it's kind of there. So this is the ping protocol. So this is calling a ping function, and this is something that was done repeatedly, so I put it in a separate function on its own. Then we have motor demand. So that's sending the demand, the motor signal to the motor in the slave IDU Arduino. Then we have a check lights function. So this is setting the maximum and minimum figures to create a hysteresis. Currently all the LEDs are switched simultaneously. That would be less likely to be the case because the rear LED would need to be able to flash under certain circumstances, including rapid braking. So there's that. This is the interrupt function called bug out, and then we go into the functions that I haven't fully completed yet. So this is where we're deciding the direction. This is where the neural net would come in and being able to help decide the direction we wanted the vehicle to go in with various inputs. At the moment, the only input is the heading as transmitted by the magnetometer. Yeah, so that's just coming through and determining it's passing through. So, but this is the point where the neural net would it be implemented to make further decisions on the basis of more information. And then we have decide the speed. So this is where the speed decisions would also be made, probably by the neural net as well. And then we have moving on to, this is the slave Arduino. So this is where we are at the beginning. And these are the settings. So these are the various headers that are called up. So this is set up. This is the loop, for loop. So there's a wire on request, which is to run the transmit values function, which I'll come to in a second. And then the main for loop has this. So this is an interrupt. So the transmit values reads the potentiometer, chops it all up, exports it, and puts it down the pipe. And then the drive motor function, which is called up here, takes in the request, the signal speed that's been given to us, and consequently pokes it out to the motor, unless there's no figure. And that concludes my